Hi everyone, I'm very happy to be talking to you at Mobile DevOps 2022. I'm Alex, I'm a tech lead at BAM. We're a mobile apps company. We develop mobile apps in Native, Flutter, and React Native. And today I want to talk to you about performance measures. And why is that? Well, first, because I really like the subject of mobile apps performance, and I think you should too, because first, a stat. This is coming from a study by AppFlyers saying 70% of users will abandon an app if it is too slow. Wow. This raises 2 points. The first one is this. Well, if 70% of users will abandon an app, it means that, you can basically throw a lot of your hard work if you develop an app and it's just too slow because basically 2% out of 3 will just throw it in the trash. But the second point is this. What does it even mean if it is too slow? Like, basically, how do you actually know if your app is too slow? How do I know if my app has good performance? And this reminds me of a client who came to us a while ago. And this client basically wanted us to develop both a website and also a mobile app. And we thought, well, cool, we like cross platform frameworks like React Native, and we could like share code between mobile and web, whatever. But what was interesting about this client was that he had very strong standards for the web app in terms of performance. He was saying that basically we should have a very good Lighthouse score. So if you don't know Lighthouse, basically it's something pretty much part of Google Chrome. You can just give it any website. It will run some calculation and give you a performance report of the page load. For example, this is performance report for google.com, which is only 80 out of 100. I was kind of surprised, but it's really awesome. Basically, you just give any web page and it will give you a performance score. And so, yeah, this client had very strong metrics, like time to interactive, Lighthouse score, which needed to be over 90 and everything. And on the mobile app, basically his standard was the app should not lag. And that was it, like not very scientific, not a very good measure. It was just like, well, it should not lag. Because pretty much, I feel like there's a lack of tooling like that on the mobile side of things. So I was interested in the question and I thought, well, what makes a mobile app performance? If you turn to Google, Google's definition is that your app should run at 60 FPS, 60 frames per second. Well, it's basically like a movie. A movie's animated pictures. An app is basically the same. Like if you scroll on Instagram, for example, the app is responsible for drawing 60 images per second while you scroll to give you an impression of smoothness. Actually, it's even more than 60, quite often 120 in more recent devices. And your app is responsible for, yeah, basically achieving to draw all of those frames in 1 second so that it it's smooth. It gives an impression of smoothness to the user. But is that enough? Well, the answer is no, because some other metrics, like CPU usage, for example, can come into play. We develop apps, a lot of our apps in React Native, and React Native has this particularity that a lot of business logic can run on a separate thread, which is called the JavaScript, the JS thread. And here, for example, I have like a very sample app with a beautiful design that I made myself. Well, I'm not really a designer, mostly on the dev side of things, which I guess shows. But basically, what happens if like you click the button, click me, and it says I've been clicked 1, 2, 3 times. But kill.js is a button which runs abominable JavaScript logic. Actually, recursively calculates the Fibonacci suite, which is pretty heavy. And basically, you will notice that if I click kill.js, I can click me, but nothing happens. It's not until kill.js has finished that you can see 3 going to 12 because I've clicked click me 9 times. You see 3 and 12. Basically here, the app is being completely blocked by clicking kill.js. However, what's quite interesting is the app is still running at 60 FPS. the app is still drawing 60 frames per second. It's just suddenly unresponsive because of heavy CPU usage. So what I'm getting at is that measuring mobile apps performance is a complex problem. First, because there are several metrics to analyze: FPS, CPU, RAM, thread by thread analysis, battery, etc. The second point is this. Yeah, it's especially true if you develop apps using a cross-platform framework, but basically if you're starting to have performance issue on a high-end device like a Pixel 6 Pro or an iPhone 13 Pro Max, probably your app has like severe issues for most of your users. Because if we take, for example, this is the Geekbench score, it grades it's basically benchmark for CPUs of phones. So this is the single core score for the iPhone 13, which is the most sold iPhone in France at the moment, which is, so the score is 1700 for the most sold iPhone. But if we take the most sold Android device in France, it's 10 times lower. Which is crazy, because if you always cater to high-end devices, or if, well, as developers, we often have pretty good devices ourselves. So if you test only on your devices, you will actually miss a lot of the issues your users could have. More interesting is this. Actually, 80% of CO2 emissions for a smartphone are due to its manufacturing, which means that basically since one of the reasons why users just give up on their phones is because their apps are getting slow, this means that performance is actually one of our responsibilities to tackle this. Because if we build performant apps, then users are less likely to change phones every now and then. So measuring performance is a complex problem because, okay, several metrics to analyze, as I said. It also, of course, varies greatly depending on the device, and you should test your apps on low-end devices. Another issue is this. Performance measures are often, well, not deterministic. Um, yeah, I mean, if you measure the start time of your app one day, the next day, like, I don't know, let's say today the startup time, wow, of your app is 3.2 seconds. Maybe tomorrow it's gonna be 3.4 or 3.3, and maybe your performance has gone worse. Maybe like you did something that aggravated, and you went from 3.2 to 3.4, but maybe it's just like randomness. So it's kind of hard to measure successfully, and well, my advice is always to iterate several times on your measure and just average the results. But to be honest, that's quite cumbersome and annoying to do. Another thing you should do is make sure to keep the same test conditions, like, for example, network reception. Of course, if you test your app in 5G, the startup time, the time to interactive of your app in 5G, and you test it in 2G, it's going to be greatly different. You should always keep the same network condition. You should always analyze with the same data on the same phone, of course, as I mentioned previously. And ideally, to be honest, the best way is to automate the behavior that you want to test. Because, for example, if you want to measure the performance of a critical path in your app, if that's you doing the critical path in your app, there are chances that the way you do it will be different from one iteration to the other. If you script it, or if you write an end-to-end test to do it, then of course it's less likely to change. It's going to be much better. All right, so there are ways to combat the fact that performance measures are not deterministic, but to be honest, it is quite annoying, right? And there is even a fourth point to this, to say that measuring performance is a complex problem. So let's say I bring up Twitter and I analyze the CPU usage of Twitter doing nothing. You can see that it's roughly like 0.5%. This is on a quite low-end Android device. But let's say that, for example, I try to measure the performance with a tool that captures RAM usage. Well, to capture RAM usage, you can use dumpsys meminfo, but the fun part is actually capturing the RAM usage like that has a big impact on CPU usage of the app. So your tooling can have an effect on the performance. Let me say that again. Basically, your performance measures can have an effect on the actual performance of the app. And that's something to be taken into account because, yeah, of course, if it's actually the way you measure that actually affects the performance of your app, what are you even measuring? And it's especially true also if you measure mostly in debug, like measure in production instead, because if you measure a lot in debug, you might actually notice some issues that you won't have in production. So yeah, measures can often be wrong or inaccurate because you don't have the right tools to do it, or you're not in the correct setup because you're measuring on debug, or yeah, need always to take care about this stuff. So all in all, yeah, I could have I could have named a lot more issues to say that measuring mobile app's performance is actually a complex problem. Very interesting one, that's for sure, but it can be quite complex to achieve something. And to be honest, if we think about what I was saying earlier, um, about the client who came to us, yeah, it it'd be really nice to have something like Lighthouse for mobile apps, like some place where you just push an APK and it just gives you the performance of your app. Well, today I am very happy to say that we're getting kind of close to that at BAM. So I would like to introduce our new open source Android performance profiler. It's available on github.com/bamlab/Android performance profiler. And so, yeah, let's see a demo first. So essentially, you would launch it like this. We'll get to how it works exactly in a second. So you launch a script. The script is going to install a C++ profiler on your phone. This C++ executable will be responsible for outputting performance measures from your phone that your laptop can, well, your computer connected to the phone can basically collect. And here you will notice that I'm actually running performance measures on the Twitter app, which is, well, production app that I do not control since I do not work for Twitter, so that's kind of nice. And what it does is it's basically running an end-to-end script to just start the app and wait for the app to be interactive. It's basically waiting for a tweet to appear. And as you can see, basically it's running several iterations, collecting performance measures, etc. It's only outputting the time to interactive in the terminal, which, as you can see, well, the video is sped up actually. Twitter startup is kind of slow. Might notice that this is actually quite a low-end Android device. This is a Samsung J3 from 2017, but our research seems to say that basically a lot of people, at least in Europe or France, have a lot of similar devices, quite low-end, cheap Android devices like 100, 200 euros, something like that. And finally, when it's done, it outputs all the measures to a JSON file. And you can use our web reporter to parse that JSON file and basically output the result. Here you get actually a web page showing the score, which is 40 out of 100, which is not good, basically. Because the app took 11 seconds on average to load. You can even see that the UI thread was kind of heavy for a while. Some other threads were quite big for a while. You can also see RAM average. You also get a graph of FPS, which is not that great on this low-end device, but this is the startup, so it's less of an issue, I guess. Total CPU usage when starting the app, averaging all the iterations, of course, and you can also see the CPU usage per thread. By default, the UI thread is selected. You will see that its usage is indeed quite high, which explains the low FPS. But you can also click on the list of threads, and you will be able to see basically all of the threads in the app, all the CPU threads in the app, and you can select whichever one you want to make some comparison, for example. And yeah, you're basically able to see all of the data that you want in this web report, which is kind of cool, I feel like. Um, all right, but one small caveat. Here I executed perf.ts. This is a TypeScript file, and at the moment, you do have to write it. So let's take a look at what perf.ts looks like. Oops, yeah, there you go. It looks like this. And if you, yeah, I don't know if you've ever done TypeScript in your life, but we're looking also to simplify this and make it way more accessible to people who have, yeah, don't want to deal with JavaScript or TypeScript. But essentially, we instantiate something to run end-to-end tests. So here it's a wrapper around WebDriver IO to run Appium test that we have. And here we create a startup test case. And we tell it to, yeah, basically what needs to happen for the TTI, so find element by ID row. Basically in the Twitter app, a row is a tweet, it would seem. So as you could see in the video before, basically we're starting the app, waiting for a tweet to appear, and then always closing the app over and over again. And this is how we get the TTI, the time to interaction, just kind of like Lighthouse, if you know Lighthouse. And then we just run measure performance coming from our package profiler / end-to-end. And yeah, basically this is what runs the test case 10 times over and write the result to the JSON file. And then as you were able to see, we're able to open that file, extract it, you get all the measures. You could even run some custom calculation if you wanted to. But then you might be wondering how it all works. I mentioned the C++ profiler that we install on the app, but yeah, essentially what does it do? Well, the good thing with Android is it's based on Linux, which means that any command that you could run on Linux system pretty much works on Android. So for example, you have top that you can run on your system usually, and you can also run it on your phone via adb shell top. You can select the process ID of an app, for example, with adb shell ptop of Twitter, Android, and what it will do is basically show something like this, which is kind of cool, I think. Because basically it gives us, with the -h option that we passed, it gives us all of the threads for the Twitter app, and it gives us the CPU usage and other data for all of the threads. You can also see residential memory, for example, for RAM usage, and other stats that you could basically extract and make your own profile. What happened is we found that it was not flexible enough. I mean, it was basically the first version of the profiler, but we wanted to measure every 500 milliseconds, and this was not able to do it. And sometimes actually running ADB shell top had a non-negligible impact on performance of the device, because running ADB shell top also uses CPU on the device. And on low-end devices, this could be an issue. But the good thing is Top's code is open source, so we're able to kind of see how it works. And basically, it reads from files in the system, and that's what our C++ profiler does. It reads from files to extract the CPU usage at least. But yeah, you might also be wondering, I said that this is an end-to-end testing tool. Well, yeah, you don't have to measure only startup time. It's true that Lighthouse does only the page start, but this is basically made to have any testing scenario that you could have. It will run it 10 times for you and output the measures. So for example, here we have a more complicated test scenario, where we just go on Twitter, we click the Twitter search, we search for mobile DevOps 2022, then we click search for, we wait for the Bitrise tweet to appear, and then we scroll down twice. You could imagine anything. You could put, your any end-to-end test here, like waiting for, I don't know, you're testing your critical path in your app. We're also looking to support Maestro here because they're doing a tremendous job in the world of end-to-end tests, and that would be kind of nice to just be able to check a Maestro flow and then get the performance. And yeah, essentially in this case, it just looks like this. Again, the video is sped up, but it's gonna take several iterations. This time doing something a bit different. It's going to go on the Twitter search, searching for mobile DevOps, like I said, etc. Scrolling twice, and then going back because I said so. And then doing it another time. It's gonna be doing it 10 times, basically, as you might have guessed, outputting the measures to a JSON file. Same as before, we will be able to open this JSON file on the web reporter, and it will look like this. Yeah, this time 74 out of 100, a bit of a better score. Do have to point out that the average CPU usage is under 100%, which is quite nice. Oh, by the way, it can go up to 400 since it counts 100 for each of the CPU cores on the device. So if your device has 8 cores, then it will be able to go up to, like, this will count as up to 800%. But yeah, we can see though that in terms of FPS, for example, we do have a bit of a frame drops that are kind of noticeable when you do use it on the lower end device. Anyway, that's all for our demo. This is our open source performance profiler. As you were able to see, well, you do have to write an end-to-end test, but it will take this test, run it 10 times, average the iterations for you. It supports native, React Native, and Flutter because, well, those are the technologies that we use at BAM, but probably it supports other technologies. If you have another framework that you use, I'd be happy to hear about it. It even supports production apps. This is my favorite. We're able to check the performance of Twitter. You could check the performance of your release candidates, of your competitors, if you wanted to, or like, compare the performance of your release app when you switch, I don't know, you make a big change, for example, switching from native to React Native, or vice versa, and you could basically just compare the performance. And of course, it can run in CI via Bitrise, for example, an emulator, or, well, I would strongly advise using real devices to be able to have like real, yeah, basically real performance data. We run it on AWS Device Farm, for example, because AWS Device Farm does have ADB support, and we need ADB support to run a lot of our commands, just installing the C++ profiler, for example. And as you were able to see, generates beautiful reports like this. This is the comparison report, by the way, so you can actually pass to the web reporter multiple JSON of measures to be able to make comparisons like this. Like I was saying, you compare release candidates, or you compare, I don't know, you want to make a fix in performance, you're investigating a performance issue in your app. You want to make sure that your fix has made it better. You should probably use this. Anyway, yeah, give the plugin a go. That's all for me today. If you have any questions, issues, remarks, critics about the plugin, feel free to ping me on Twitter or GitHub. And yeah, thank you for watching. I hope you enjoyed it, and see you around.